So hello all of you. So we are back with the almost towards the end of the class 12 session where we are going to discuss today the sample paper CBSE class 12, which is of 70 marks paper. You should also know it's comprised of section A, section B, C, D and E. Okay, so we have 5 sections in total. Section A comprises of 16 marks, 1 mark each. Here you have 1 mark question, MCQs and assertion reasoning question. Okay, section B is 2 marks question. You don't have a choice. I will just check once more. And then section C, 3 marks question. Then D, we have a 4 mark question, which is a case based questions or paragraph based question. Now this year in the sample paper, the paragraph that they had given, you have to search answers in the paragraph. It's a change we found in the sample paper this year, but we are not quite sure whether the same thing will be coming for the boards also. Like as you know, they give a paragraph of course, but the paragraph, we don't get answers in the paragraph. The paragraph is based on a topic, but then the questions which are given with respect to the paragraph is questions which are conceptual, which you have learned it from your textual part. But this time the questions that they have given, the answers you will be getting in the paragraph itself. So there's a small change we found, but still I repeat, we are not quite sure whether the same thing will be happening for the board exams also. But the section D is a case based questions. You have 2 questions, question 29 and question 30. Last section that we have, it's a 5 mark question section, section E, and there you have 3 questions. But the advantage here is that for all 3 questions you have an internal choice. But I repeat, it's an internal choice. Internal choice means that if you have the question from solution chapter, the OR question will also be from a solution chapter. So it will not be like this that you can opt to study a chapter less. Suppose you think, okay, I will attempt or maybe I can skip electrochemistry a bit, but no. Here in CBSE board, the choices are internal choice. Okay, so if you have a biomolecule chapter question, the OR question will also of course be a different question, but it will be from the biomolecule chapter itself. Okay, so we call it internal choice. So there are 3 questions with ORs in each question. Besides that, in other one section, it's a 3 marks question, section C. There you have 1 choice. We'll see that you get it that every year. It will be like this. It is not choice how out of 4 questions you have to attempt any 3. So that's the choice you get there. Okay, so that's all. We'll start the class right now. But then before we start, not to forget, yes, we are at Manocha Academy. So you can log into the website and check the details of the different classes. And since now in class 12, we already are aware of the details. So please share with your friends and family, your juniors, so that we can increase our community. So with this, let's start today's class. Okay, nothing in the chat line, so I start. So I've been telling you all this. These were told to you already. Okay, so whatever I told you, it's mentioned here. Yes, now we come to the MCQ part of the question. Okay, yes. The question is telling us which of the following reaction lead to the formation of ethyl methyl ketone. Now, whenever you get such a question, first thing is you will be writing the structure of the question part. So it's best to do that. Otherwise, these type of questions becomes a bit difficult to answer correctly, because you will also be, it's the first question, so you'll be a bit tensed also. So you write the structure ethyl methyl ketone. So yes, so first thing you write the structure of the question given. So ethyl methyl ketone means we write ethyl. This is the ethyl group. It's a common name given, not the IUPAC name. Ethyl, since it's a ketone, so it's a keto group here, and methyl. So first thing we write out this one. Then looking at this, you can see it's a ketone. So primary alcohol given means we know that oxidation with primary alcohol strong always gives an aldehyde. It always gives an acid, carboxylic acid. So first thing we know, it can't be a primary alcohol, because primary alcohol will not give us a ketone on oxidation with acidified potassium sodium dichromate. It will give us corresponding carboxylic acid. So in that case, this is wrong. Now, here you see CH3C, here it is CHOH. It's a printing error. Anyway, it's a secondary alcohol overheated with copper Yes, it's called dehydrogenation reaction if you remember. Secondary alcohol of course gives a ketone, but if you look at the structure here, you can understand the ketone for B is actually nothing but propanone or acetone. Look here, from this you're getting this. So then not this. So this is also cancelled. Now, next part is if you ozonolysis of this one, I hope you remember class 11 concept also, which we have in class 12. We know that where you have the double bond on ozonolysis, this double bond gets removed and to those carbons double bond O gets added. That's the concept. I repeat, where the double bonded carbons, the double bond gets removed and to those double bonded carbons, double bonded O gets added. So taking that into account, if you look at this structure, to this C double bond O, to this C, what is there? CH is there, CH3 is there. So one part you are getting this ethanol, and from the other part here what you are getting, this is a double bonded carbon. To that a CH3 group is bonded. I write a CH3 here. Then CH2, CH3 is written here. CH2, CH3 is written here. So I rub this because this is not the, you'll get confused. So you get here this plus this, right? So this is the corresponding with this structure. So from here we see that ozonolysis is the correct answer. We'll also check with this because this is a very important reaction. It's a very important reaction. And here I would like to add one more thing for this reaction. How do you know what ketone? Because this reaction is also required for conversion purpose. If ever you are told to prepare a methyl ketone, I write this. From which alkyne will you start? How do you decide that? First of all, always remember one alkyne gives a methyl ketone except acetylene. So this one we know that acetylene will actually give us acetaldehyde or ethanol. But I would like to also show you this one. Suppose I write here CH3, CH2, CH2, C, triple bonded CH. Okay. Now, to this, under this condition, mercury sulfate dilutes sulfuric acid. What happens to this? What happens is Markovnich's addition of water take place. Here to this carbon, hydrogen is added, to this carbon, OH group is added. So I'm doing that in one step. So to this, hydrogen is added means you're getting CH2 and double bond here, and to the other carbon, OH group is added. And then tautomerism take place, from where you get CH3, CH2, CH2, C double bond O, CH3. And I'm writing once again the alkyne CH3, CH2, CH2, C triple bonded CH, C. Now you compare. These three are alkyl groups, these three are alkyl groups. Now what happened is, this one alkyne, from one alkyne you actually get a COCH3 group. Always. The C triple bond CH will always give a COCH3 group. So suppose you are given a conversion where you are told to prepare RC double bond OCH3. This R can be butyl, isopropyl, whatever it is, doesn't matter. You only have to know that this unit, COCH3 unit, comes from a C triple bond CH group. Okay, and accordingly you choose the starting material is dependent on this R. So any methyl ketone you can prepare from an one alkyne except acetylene. In acetylene the difference is I'm going to show you that also, but this is very important for conversion purpose. If you get a conversion to prepare any kind of methyl ketone somewhere or the other, always remember one alkyne. One of the very popular method is this. Now coming to acetylene, I move to the next slide to show you that. In acetylene what happens, since it's both R, it's not having any R, no. It's when you add water, that is dilute sulfuric acid mercury sulfate condition, to one hydrogen is added, to the other OH group is added. Here there are no alkyl groups, that's the reason you get a CH group. That's the only thing here. So anyway, this CH gets converted to CH3. But since to this C there is no alkyl group, there is a hydrogen. So instead of ketone, you get an aldehyde. Simple as that. So that's the reason you get here CH3, CHO. That is what you get. Okay, I forgot this hydrogen here. So coming to that, the correct answer is option C. So option C is the answer. This is a very, very good question. So question can come differently, but you have to analyze why the answer is this. Okay, so I'm moving to the next one. Oh, this answer I have already told you. So it's there. Now, this question I'll be discussing with something else also, but look at this question first. It's again a very good question. Now, as you can see, alkyl halide, ethanolic sodium hydroxide, we know the product is an alkene always. But alkene preparation, mainly we have two methods. One is from alkyl halide, one is from alcohol, isn't it? For alkyl halide, we use ethanolic KOH or NaOH, and for alcohol, we use concentrated sulfuric acid. But there's a basic difference between the two. What's the basic difference? Like this one, here the elimination is E1 elimination. Here the elimination is E1. That means take place in a single step, where the bond breaking and bond making are concerted. There is no intermediate formed. So as a result, here there is less possibility of the Sergev product being formed. Like here, if I show you this, it's butyl. So I'm showing you how it happens. CH3, CH2, CH2, C1, 2, 3, hydrogen, CH2, Cl. This is the structure given to us. 1, 2, 3, 4, 5 I made. 5 I made by mistake. I'll reduce this. This I'll make it 3. This is C. So 1, 2, 3, 4. 1, 2, 3, 4. Yes. Now here the mechanism is this. As I told you, it's a concerted mechanism. The OET minus group, it's ethanol, no? OET minus is the base which abstracts the proton. Okay. And accordingly, this is going here and this cleavage is taking place, from which you are getting but-1-ene. So here the competitor, Sergev stable product, but-2-ene, has less possibility of formation. The reason being is because here there is no possibility of the rearrangement taking place. So here the but-1-ene is the product. But if the question came like this, that you have a butanol with concentrated sulfuric acid, then the major product would have been not but-1-ene, then the major product would have been but-2-ene. Why? I'm showing you that also. Suppose you're given butanol. This is given to you. Then what's the step? What happens? Concentrated sulfuric acid step. First, the OH group is getting protonated, and then after that, this gets removed. This is the RDH step, which is the slow step, formation of the intermediate carbocation. And you get here CH3, CH2, CH2, CH2 plus. It's a 1 degree carbocation. So we know hydride shift take place. Hydride shift take place. And you get here the 2 degree carbocation, the most stable one. This you get. The rearrangement is taking place. I'm not writing so much in details. Hydride shift is taking place to form a more stable carbocation. This is possible. Why? Because you're having an intermediate here. And here the stability of the intermediate is very important factor. So 1 degree carbocation moves to the most stable 2 degree carbocation. Now since a 2 degree carbocation, here you have two options, that from here the hydrogen gets eliminated if you get but-1-ene, and from this carbon, because we know it's beta elimination, from here also the hydrogen get eliminated, you get but-2-ene. But as the Sergev rule tells us, Jetsev rule also you pronounce it, tells us that the more substituted is the alkene, more stable it is, and that is formed as a major product. So in that case, you get butene as the major product. Then the answers would have been different. Okay, I'll tell you what. So if this is this, then the butene would have been the product. But actually in the question that is given here, here the alkene here is butanene. So I'm writing that. Here the alkene is butanene, which is not asked us. The question comes from next part. Now, this is Marconi-of addition. Accordingly, Marconi addition means H gets added here, OH gets added to the second carbon. So butan 2-ol is the product. So B should be butan 2-ol, which we have only in one option. So we don't have to look at the other option also, but still we'll look. And this is B2H6 conditions means anti-Marconi-Huff product we get, where butan 1-ol is the product, isn't it? So naturally we choose option C as the correct answer. But as I told you, if this question was given, the which one we discussed, where butene is the major product, then whether you use water H plus condition or you use dibodane B2H6 condition, the answer is always butan 2-ol, because it's a symmetrical alkene. Here Marconi-Huff, anti-Marconi-Huff is same in this case. So in that case, the answer would have been both are butan 2-ol. So these things you have to analyze when you are doing questions and answers, and answer accordingly. Okay. But anyway, so here is the answer for this one. I hope till here everything is clear. I'll move to the next MCQs. The MCQs given are really very good ones. So you have to, and that's the first section. So be patient. I mean, try to keep yourself calm and cool, and then start your exam. Okay. So this part I have already discussed with you. So answers I am not discussing from here. Now, this is a very easy question we got. This is an easy one, third question. The counter and the coordination compound, but still not to forget, this is the coordination sphere and this is the ionization sphere, and ionization sphere contains the counter ion. So here the counter ion is chloride. So here we go as chloride. We know that's metal, ligands, counter ion. So that's the answer. Okay, this is done. Now, what is this question? Let me check. Okay, organic compound A, B and C are amines having equivalent molecular weight. That means they are primary, secondary or tertiary amines, isomeric amines. A and B on reaction with benzene sulfonil chloride, that means Hinsberg reagent, gives a white precipitate. So both A and B is giving a white precipitate, means both A and B are possibilities are primary and secondary amines, right? However, white precipitate obtained from compound B remains insoluble in NaOH. That means B is told to us, that means B is a 2-degree amine without doubt, right? So now we know that A is 1 degree, B is 2 degree and C is not reacting with the Hinsberg reagent itself. So it's obviously a 3-degree amine. And we know more the branching. Here the question is asking us on the variation of boiling point. So more branching means of course lesser boiling point. So A, and it's increasing, okay, A will have maximum boiling, okay, here you tell me the answer. Secondary and tertiary, you also have to consider boiling point depends on the intermolecular hydrogen bond for the amine part, isn't it? And for primary amines, if you look at this is one hydrogen, this is one hydrogen. This can form intermolecular hydrogen bond with another one amine. If I take here, this also can form, isn't it? So molecule becomes more associated. For the secondary amine, you have not only it's more branched, but it's also having one age group available for intermolecular hydrogen bonding. For tertiary amine, so no hydrogen bonding is also possible. So quite obviously A should have maximum boiling point, then B, then C. So in this case option A is the correct answer. Is it okay? Okay, so there are two things we have here. First of all, we know more branching, lesser the boiling point. That is of course applicable. Doing that also you can answer. Besides that, you can also think of the intermolecular hydrogen bonding. If the question comes not in MCQ format but give reason, so you have to give two reasons. One is the more branching reason. The other one is that the primary amine is having two NH2 groups, two hydrogens attached to NH2 group it is having. That means it can form hydrogen bonds from two ends. Intermolecular hydrogen bond. For secondary it is only one NH group, and for tertiary amines there is no hydrogen available for intermolecular hydrogen bonding. So for this, A is the correct answer. Now moving to the next question. Achha, this is a numerical based question. The 70 gram of solute dissolve in 700 gram of solvent. Whenever you get such question, always write like this. 70 gram of solute means solute we take as W2. Always solute we take as 2 and solvent we take as 1. Solution chapter, if you look back, that's the convention generally we use here. And 700 gram of solvent, this is W1. Okay. To prepare a solution having density 1.5 gram per ml. Now, ratio of molality by molarity. You might think a lot of calculation, but yes, here we are not going to go deep into the calculation. What we are going to do? First of all, we'll find a molality, which is very simple out here. So, we find a molality. Molality we know, number of 70 gram of number of moles of the solute means 70. Molecular mass we don't know, I'm writing as MW. Okay. By, this is number of moles present in 1000 gram of the solvent, but here it's present in 700 gram into 1000. This is what you get for molality, isn't it? Number of moles means weight by molecular mass present in 70 amount of the solvent 700 into 1000 kg we are converting. This is M we are getting. Now, coming to molarity conversion. Now, here for molarity, volume of the solution is to be considered. Now, we don't know the volume of the solution, but we know the mass of the solution, isn't it? So, I write here mass of solution. So, mass of solution is, we know that 70 plus 700 gram, which is equal to 770 gram. Now we have to convert to the corresponding volume of the solution, and we have the density term out here that we'll use here. So density equal to mass by volume. Density given to us is 1.5 equal to mass we know as 770 by volume. Right? So volume becomes 770 by 1.5 ml. This part we get volume of the solution. This is volume of the solution. Now coming to molarity, I am writing here as capital M here. Number of moles of the solute, which is 70 by W, same thing, 70 by MW by, here you have this one, volume of the solution in ml is this one, 770 by 1.5 into 1000. Okay. So from here, now you find out molality by molarity is small m by capital M. So small m is this 70. Okay. Here MW into 700 into 1000. Okay. This divided by same thing 70 by MW into 770 into 1.5 into 1000. Just check whether run it all correct. So we are getting here 70 into, this is 700, no? 70 by into 1000 here. Oh, sorry. Yes. So 70 into 1000 into, here we are getting MW into 770 by 70 into 1.5 into 1000. So most of the things gets cancelled out here. 70, 70 gets cancelled, MW, MW gets cancelled, 1000, 1000 gets cancelled. So it's left only 770. That also here also it gets cancelled. In fact, if you take as 15, it will be 7700, 200s also get cancelled. Okay. So the calculation now becomes very simple. So instead of calculating separately molarity, and then you do it at the end. That is what I prefer it. So after doing this, you will get the answer as this, 0.73. If you calculate it, you will get the answer as 0.73. So in this case, the answer is 0.73. This is the answer. So you see, MCQs are not very simple. So I move to the next slide. Next question. This is an easy question we got. Okay. This see, here you are having OH, HCl, you are getting, in place of OH, you are getting a Cl group here. Okay. Here you have a Br, the leaving group. Here you have a OH minus is attacking here. And what you get instead of Br, you are getting OH. Not only that, it is inversion of configuration. Have a look. It's inversion of configuration. So inversion of configuration means SN2. So B is 3, which is SN2. Okay. Next, here you get an alkene from an alkyl halide. So without doubt, it's an elimination reaction. So elimination is 2. So C is 2. This one. And you have an alkene HI and you are getting 2 products. Of course, it's an addition reaction to an alkene when you are getting 2 products. Why? One is the Markovnikov product and one is the anti-Markovnikov product. That is what they meant. But the thing is an addition reaction. So D is 1. D is 1. So I write here, this is D, 1. Oh, this one we did not write. Okay, sorry. Here is OH group and here is Cl group. And what we observe is here is no inversion of configuration, whatever it is here. In this case, we take it to be an SN1 reaction. So here it is an SN1 reaction according to that. So we'll compare here B3. B3 we have for 2 options. Then C is 2 we have for this. That also we have for D option. Then D is 1. D is 1 for this option. So this is the correct answer. Oh, this one I missed out. A is SN1. So this is 4. So now we match it. A is 4, B is 3, C is 2, D is 1. So option D is the correct answer. Okay. Next question, answer, leave it. This is again a very simple question. We have, of course, all the questions can't be tricky. Then how will the students fare up, isn't it? So cresol. Now, do you know what is cresol? Common name? Anybody? What is cresol? One is all means one OH group is present. That's for sure. Now, what is the cresol? Other than OH, what other group is present in the benzene ring? See, cresol means it has to be one OH group. But even if you don't know, it's orthocresol means it's a CH2 group. Even if you don't know, don't get terrified because that is not required here. Because it's telling us the OH group is attached to the carbon atom. That is what hybridization. So they are indicating on this carbon atom. And we know that benzene ring carbon atoms are sp2 hybridized because it's a planar molecule. So the correct answer in this case is sp2 is in option B. So this is the answer. Okay. So next question we move on to. Okay, done. Which of the following is laboratory in nature? We miss reading this off, but can you tell me which is levorotatory in this one? Which option? Alpha D, beta D, beta D. First is glucose, then is fructose, and then is sucrose. Which is levo? Anybody? Now, one more thing let me tell you. Alpha, beta, they are there to confuse you. Because levo or dextro doesn't depend on the anomers. Isn't it? Because we know their anomeric carbon means configuration of the first carbon atom is different. The rest configuration remains same. So whether it's alpha, beta, the levo or dextro doesn't change. For alpha D glucose or beta D glucose, both are dextro. We know that. So which is levo? Nobody? Remember, glucose is dextrorotary, fructose is levorotary. Okay? So we have here fructose. Whether it be alpha or beta, it's the same thing. It's levo. Okay? Next, this one to answer. Okay. Name the inner transition metals. The name inner transition metal is often used to refer to lanthanoids, actinoids, both lanthanoids and actinoids, D block elements. It's again a simple question. Inner transition elements means F block elements. We know that. Transition elements means D block elements. F block elements means there are two elements, lanthanoids and actinoids, 4F and 5F series, right? So here, obviously the answer is option C, lanthanoids and actinoids. That's the correct answer. With this, I move to the next one. Okay, this is the answer part. Okay, now, this is coming from limiting molar conductivity. Lambda M0 of acetic acid can be calculated the values of the following. We know that. Yes. From here we are getting CH3CO minus plus K plus, right? Here the K plus plus Cl minus. And here H plus plus Cl minus. So we can understand that this Cl minus gets cancelled, this K plus gets cancelled, so CH2CO2 minus H plus is remaining. Here if you see, K is not getting cancelled here, right? Sulfur is not getting cancelled here. So without any doubt, it's either 1 or 2. Let's take the 2 ones. Na and NAs get cancelled. Cl minus, 2 Cl minus are here. Okay, this Cl minus is there, but then from where will K gets cancelled? And where is the H plus ion? Not there. So 2 is also not there. 1 or 3 also we'll check 1. 3 is sulfuric acid sulfate. Okay, this one we check. Oh, from here let us see. Here you have 2H plus. Here you have sulfate. Here you have 2Na plus. Here also we have sulfate. Okay. Here we have CH3CO minus plus Na plus. That doesn't matter. Here you have 2H plus. So we can make it this also 2. So here again it's getting cancelled. Sulfate getting cancelled. Sodium is also getting cancelled. H plus and H plus we are getting. So it can be, what should we think you the answer? 1 or 3? Both should be right, isn't it? So 1 or 3 should be the correct answer. Yes. Okay, done. So after this, yes, we'll move to this question. Which of the following will give a yellow or orange PPT with 2,4-DNP? Now, we know that ketones and aldehydes both respond to 2,4-DNP test, but carboxylic acid doesn't. So keeping that in mind, so propanol and propanone both will give, but propanoic acid will not. So 1 and 2 should be the answer, which we have in option A. Yes, so carboxylic acid don't respond to this test. So 1 and 2 should be the correct answer. So this is the answer. Do you agree, all of you? Okay, fine. So with this, we move to the next question. Okay, this was the answer. So now, identify the secondary benzylic halide and primary alkyl halide. Now, benzylic halide means the halogen bonded to the benzylic carbon. And which is the benzylic carbon? The carbon bonded to the benzene ring is the benzylic carbon, right? So, first we look at second, and that's all secondary benzylic. Now, benzylic is here, no halogen, no halogen. Here we have, so the benzylic carbon of the 4 structures, we have only one which is benzylic. And of course, this is a secondary one. You can see here. Why secondary? This carbon bonded to one carbon here, one carbon here. So this is for the first one, it is 4. And primary alkyl halide, we have it only here. This is a primary carbon and this is primary alkyl halide. So it is 2. So 4 and 2 should be the answer. 4 and 2 is in option B. So this is the correct answer. Okay. This was the answer, so leave it. Next one. Now we have come to the, so question number 1 to 12 is an MCQ questions. 13 to 16 is they are assertion reasoning questions. Now, secondary aliphatic amines react with nitrous acid to form aliphatic diazonium salt. Will not go to the rest of the question. First of all, secondary aliphatic amines do not react with nitrous acid. That's a test for primary amine. Primary aliphatic amines give diazonium salts which are unstable and they liberate nitrogen gas. So first statement is itself false. So if it's one of the statement is false, the answer becomes very simple, isn't it? So A is false. Even if we don't know this, doesn't matter, we know this has to be true because both are false option we don't have. So this I will not, even since we have less time, so you might even skip, but still if you, of course this is also knowledgeable. Have a look. Nitrogen gas evolved on the reaction with nitrous acid can be used for estimation of proteins and amino acids. This is mentioned in your biomolecule chapter. So this statement is true. So A is false, R is true, we have in option D. So option D is the correct answer. Okay, with this the next question. Okay. This was the answer. Now, care should always be taken to ensure the solutions that flow in the bloodstream are of the same osmotic pressure as that of the blood. Yes. The care should always be taken that ensure the solutions that flow in the bloodstream are of the same osmotic pressure as of the blood. Yes, sodium ions and potassium ions are responsible for maintaining the proper osmotic pressure balance inside and outside of the cell organisms. That's true. It should be option B. Both the statements are true, but it's not explaining the assertion kind. So we'll check the answer of what I thought. Yes, as you can see, the option is B because both the statements are true. But then why the osmotic pressure needs to be same? Because that's not the reason. We know to avoid exosmosis or endosmosis. Both are not good for the cells. We have learned that. Either the cells will shrink or the cells will be fluffy and they might even burst. We know that for both. So to avoid endosmosis or exosmosis, we need an isotonic solution. Isotonic solution means both the osmotic pressure inside and outside is same or is equal, right? And we also know that these ions are responsible for that, but that is not the reason for A. So with that, so both the statements are true, but the R is not giving the explanation of A. So here we have option B as the correct answer. Okay. So with this, I move to next question. Oh, this was the answer. Okay. Now, starch forms colloidal solution with water. Yes, of course. Starch contains 80 to 85% of amylopectin, which is insoluble in water. Yes. Both are true. And why starch is forming colloidal solution, not a true solution? The reason being is this. Because amylopectin, starch is components, we know amylose and amylopectin, of which the amylopectin is the major component of starch, because amylose is soluble and amylopectin is insoluble, and that is the major one which is insoluble in water. So that's the reason why starch forms a colloidal solid with water. So here both the statements are true, and the reason behind it's also explaining the reason of A. So here the option A should be the correct answer. So we'll recheck with the answer also. Yes, it's A only as we have discussed. Okay. So with this I move to next question. Secondary cells are used in inverters. Yes, tell me, is it true or false? Coming to next one, a primary cell can be recharged by passing current through it. Of course not. Secondary cells only can be recharged. Primary cells, we know once the battery is gone, it's dead, you can't reuse that, isn't it? A simple watch battery, a remote battery, those are all primary cells. So the thing is, we know this is false statement. Even if you have forgotten the secondary cells which whether they use in inverters, you at least know that secondary cells can be charged, recharged and primary cells cannot be. So they are dead means you have to throw them off. So naturally this is false, other has to be true. True, false statements options we don't have here. So A is true, and R is false. We have an option C. We have an option C. So we'll check the correct answer. We'll check the answer once with the sample paper part. So as we see, it's option C. Okay. So now we have come to, okay, yes, for question number 17, I missed this out. I was not able to remember that point of time. Yes, for section B, the first question that you get, question 17, there you have an internal choice. So in B, now you have one internal choice for question number 17, but this format is also maintained for your board exams. Format of the question that you are getting, that format will be maintained for your board exams also. So we have on an OR question, we can decide which we want to attend, but here we'll discussing both the ones. Now 50 ml of phenol and 50 ml of aniline are mixed. Predict whether the volume of the solution is equal to or greater than or less than 100 ml. So here they're asking about delta H is less than 0 or, sorry, not delta H, delta V they are asking us, sorry. Delta V is less than 0 or delta V is or I'm writing it here, delta V is greater than 0, and this depends on what? Depends whether it's a positive deviation or negative deviation. For positive deviation, positive, remember like this. So for positive deviation, delta V is positive. For negative deviation, delta V is negative. So in this case, phenol and aniline, if we compare, it is a negative deviation example. So for justification, we are going to mention this negative deviation of Raoult's law, where negative deviation means vapor pressure is less. Vapor pressure of the solution is lesser than that of the corresponding solution components, right? So that is vapor pressure is less means vapor pressure is, when vapor pressure is less means what? That means the AB is stronger than AA or BB, right? So the reason here that is given a textual part is there is hydrogen bonding, intermolecular hydrogen bonding with phenol itself as well as aniline itself. But the intermolecular hydrogen bonding between phenol itself and aniline itself is stronger than that between phenol and aniline. So it shows negative deviation. So justification will be that, and the answer to this negative deviation means, as I told you, the volume will be less than the components. So 50 plus 50, 100. So answer will be less than 100, and you're going to mention here, this is an example of negative deviation where the AB interaction is weaker than AA-BB interactions. So that is your justification answer. Okay. Now, Rite suggested adding salt to the box containing ice. He said this would keep the cold drink bottles cold for a longer time. How Rite justify this suggestion? Now, the thing is, many of you will be writing like this, the freezing point decreases, so and so, but you have to use the correct words, the key statements. Depression of freezing point. And one more thing you have to add, it's better though it's not mentioned in the answer key here. See, salt is what? It's a non-NON. See, what am I writing? Okay. So salt, a non-volatile solid solute, okay, that causes the depression in freezing point. So that depression of freezing point has to be mentioned. Okay, and that's your justification part. Okay, so for that you have 1 mark plus 1 mark for this. Okay, and this is the answer. And here, this is a very good question. The first question is a very good one. Look here. They have given you an information. Barium chloride in reaction with sodium sulfate in aqueous solution gives a white precipitate. They have given you this information. Now what they are telling you, if the two solutions are separated by a semi-permeable membrane, will there be an appearance of a white precipitate due to osmosis? Most of the students miss thinking of these things because we have seen while asking students of this type of questions. Here you have to understand the solutions. When you add one solution to the other, the chloride, the barium chloride with the sulfate, then only the barium chloride is reacting with sodium sulfate. Exchange of ions is taking place, double displacement reaction taking place, where the solutes are combining among themselves. Only then you are getting barium sulfate. But for osmosis, what we know is that only the solvent molecules traverse from across the membrane. The solute molecules don't. So naturally, only the solvent from barium chloride and the sodium sulfate, solvent from sodium sulfate, depending on their concentration, they will move across the membrane. The solute particles will not. That's the reason here the answer will be no formation of precipitate. And you're going to justify that only, that during osmosis, only the solvent molecules and not the solute molecules, they move across the semi-permeable membrane. So that's the answer. For half marks will be no precipitate formation, and the other half will be that you are going to mention this. The key statement will be that only the solvent molecules move across the semi-permeable membrane during osmosis. So that will be your answer. Okay. Now, why does water stops boiling when sugar added to boiling water? This question, the previous question is same. Only you are going to add here non-volatile solid solute, and here the thing is, since it's boiling, leads to elevation of boiling point. So elevation of boiling point means, of course, it will stop boiling for some time, because at 100 degrees centigrade is boiling means what? At that temperature only the vapor pressure becomes equal to the, we don't have to write so many, this is just for explanation. So here answer will be only on adding a non-volatile solute like sugar, that leads to the elevation of boiling point. So whatever is mentioned in the question, that's it. Okay. So next question. Oh, this is the answer part. Question number 17 done. Consider the graph. Now, calculate the enthalpy of the reaction and activation energy for the backward reaction they have asked. So, enthalpy means the height. Height I am going to consider, since backward I am going to consider from here. My line is not straight, and top here. So, this one is 100 and the hill more or less it's 140. Okay. So, final minus initial energy we calculate like that. So 140 minus 100 becomes 40, right? That is. And how will the catalyst affect the rate of this reaction? That we know, that the catalyst will lower the energy of activation, and as such will increase the rate of the reaction. That's it. Gone. So this calculation, okay, enthalpy also is mentioned. No, I forgot that. I told only the activation energy is this. And enthalpy, of course, is, I'm using a different color, green. This is product. This is starting material. Product energy, we know it's 100. And this H is 110. And here again, delta H backward means this is final. So it is 110 minus 100. So it comes up to 10. And here unit is given here. Unit is not given here. So I can take joules, or unit should have been given, but nothing is given in the unit. So I can take joules per mole or kilojoules per mole can be the answer. And activation energy also I mentioned. Activation energy is from here. So 140 minus this one 100. So it's 40. So that's the answer. Okay. So here they have mentioned kilojoules, but in the graph, I don't know whether it's there in the question paper, it is missing here. If not mentioned in the graph kilojoules or joules, you can write either of the unit, but don't miss to write the unit. Okay, in this part, I'm not seeing joules or kilojoules mentioned anywhere. So it's up to you. So you can either write joules per mole or kilojoules per mole if nothing is given, but you write. Okay, that's all with this question. Now, we'll do conversions, but before that, I'll take a small break. You can try this on your own. Did you try? Okay. When you get conversions, what you need to do is, first thing is you'll write both the structures, always, and we'll think backwards. Like for example, here it is nitrobenzene to 4-bromobenzene amine, or benzene amine means NH2. Oh, I read something else. 4 bromo. So when you want to write this, it becomes easier. Why it's become easier? You know that you can convert a nitro group to a NH2 group by using a reducing agent like lithium aluminum hydride, tin HCl, FeHCl, hydrogen palladium. You have different options. We know we can convert a nitro to NH2 group. But here the product is 4-bromo, and we know that nitro is a meta orienting. So first, and we know that amino group is orthopara orienting, but yes, it is a highly strongly activating group, but we also know that we can control the activity of NH2 group by converting to a NHCOCH3 group, acetylation. So we are going to follow that in the conversion. So which we'll see in the solution. This is the first part. Second part I am writing chlorophenyl methane. Okay. So methane is CH4. To that methane group, you have a chloro group and you have a phenyl group also. So it's PH I am writing. Rest of them are hydrogens. Okay. To 2-phenyl ethanamine. Ethanamine means 2 carbon atoms to which amine is bonded, NH2 group is bonded, primary amine. 2 position you have a phenyl group, first position, second position. So here you have a phenyl group. The rest I fill them up with hydrogens. Now, here you can see 1 carbon atom has increased, and that increase in carbon atom we can do by introducing a CN group. Why we know that? Because from Cl you get Cn, and Cn when you reduce with hydrogen palladium or lithium aluminum hydride, you can use these 2 reducing agents, not all. Then Cn gets converted to CH2 NH2. So you can see this Cl is getting to Cn, so 1 carbon is already introduced here or added here, and that carbon is getting converted to a CH2 group. So keeping this in mind, we look at the solution. Let's see how they have done it. As I told you, here nitro to NH2, here you can use even not only this, you can use lithium, aluminium hydride, that is also accepted. Hydrogen palladium is also accepted. You get NH2, then you have to control the reactivity, otherwise it will give 2,4,6 tribromo compound. So you're controlling it by acetylation presence of pyridine. You're getting NHCOCH3, and then you're doing bromination in presence of acetic acid as a solvent. You get here para-bromo as the major product, and further you can do either acid or basic hydrolysis. You get this. This conversion even came last board exam. Last board exam there was a conversion based on this concept only. Okay. When in this sample paper, this year's sample paper also, they have given this type of question. Okay. And the next one, as I told you, CH2Cl, KCN, you get the corresponding cyano. Cyano you can reduce by lithium aluminum hydride, or here also you can use hydrogen palladium, but nothing else. Sodium borohydride and all those, they do not reduce cyano to CH2NH2 group. Keep that in mind. And here ultimately you get the amine. So conversion is done. Okay. So I can proceed. Here is a good question. It's not a tough question, but we have to still a recapitulation type of question that if the IUPAC name is given to you, how you write the formula. You get 2 type of questions. One, you get the IUPAC name will be given to you, write the formula, or the reverse. Okay, formula will be given to you, write the IUPAC name. So we'll do this first. So diaqua means water. Di means 2, I write it down. Then diaqua silver 1 is given. So silver is here, I write here silver. Oh, since you have another one, argentate, so we know that in this case, both the cation and the anion are coordination spheres. Okay, so I have this. What is the coordination sphere? Next coordination sphere I am writing. Dichlorido means Cl2, argentate means silver, but since it's present in the anionic coordination sphere, it becomes an 8. If you remember, that's the metal when 8 is added indicates that the coordination sphere is anionic. So here it is Ag and Cl2. Now you can check the charges now. Okay. So here it is told silver 1. So I'm writing something else. Silver 1 means it is +1, this is 0. So total coordination sphere charge should be +1 here again. Here also it is silver 1 and it is chloride is -1. So 2 are there, -2. So -2 plus 1 is -1. So we can see here charges are balanced. So in that case structure is this only, no whole twice or anything is not required. I'll make the required. So this is the answer. Okay, to the first one. Coming to the second one. Dihydroxido. Hydroxido is OH. It's whole twice. Bis triphenyl phosphine. Bis means 2. Triphenyl phosphine is PPH3. It is bis means twice. Nickel is present, so I write here nickel. Now we'll check the charge. So nickel 2 is mentioned here. So we'll write the charge. So it is +2. Each OH is -1. So with 2 it is -2. And this is neutral. So +2 -2 cancels. That means the coordination sphere will not have any charge. So that is also important. If there had been a charge, we have to place the charge outside. Okay. So it's getting cancelled. So in that case, it's without any charge. So the answer is this only. Okay, so it is 2 marks question done. 1 + 1, 2 marks. Yes, the answer is given. You can have a look. Next. Acha, this is a question which has been newly introduced. We never got such type of question. Here mechanism is given. Though it's, I don't know how well it came. Mechanism is given, but you have to make the required corrections. So we'll check. Now, here it's an alkene reacting with water. Okay. So you can have a look at the this is plus, then to this water is getting added. It is plus, perfect. Then water is taking up this, and this is again wrong. This is okay, taking up this arrow will come to this, and you get accordingly H3O plus. Okay. See, so you can have a look here also. Look at the arrow change is very important. Look here, I repeat. Here, this is a proton. The proton doesn't come. The electron pi density always is taking the proton to itself. So here the arrow is given this, I have made it this. Okay. Now, after this, the water is adding here any of the carbon atoms because it's a symmetrical alkene. So Markovnich's rule doesn't add here. So work here rather. So you get a carbocation, though here it's not mentioned slow or fast, but this is a slow step. Okay, once the carbocation is formed, then to the carbocation the proton is acting. This is correct. The proton is bonded to this, and after this it is OH2 plus. Now this water will uptake. This is correct, but then the bond is shown that this O to this, but no, the bond is reverse. This OH bond is neutralizing this to alcohol. So accordingly is this answer. So it's 2 mark question. So 1 + 1, 2 marks. Okay. So with this I move to the next question. It's a numerical question. See, it's using a formula. I'll not solve it here. We'll look at the solution directly, but I'm telling you what will be the vapor pressure of 1 molar solution means. Here M is given equal to 1. Molality is given to 1. Okay. Of MgCl2. Now MgCl2 is, it should have a Van 't Hoff's factor. It's electrolyte. Dissociation of MgCl2 is 70 mole percent. 70 mole percent means 0.7. Right? Vapor pressure of pure solvent at 25 degrees centigrade given to be 23.8 millimeter. So that means here we know that P10 minus P0 by P0 equal to mole fraction. That is relative lowering of vapor pressure, delta P by P0. If you remember, where the P0 value is given to us, and molality of the aqueous solution is of MgCl2 is given to us. So taking that into consideration, here you can have a look. PA0 23.8 is given to us. Molality, as we have discussed, it means what we know, that 1 mole within 1000 gram of the solvent. Now 1 mole and here 1000 gram. So from here you can find out the, because X2 means mole fraction means what? N2 by N1. I missed out writing that. This means N2 by N1, and this means what? N2 we know, W2 by W1. Here, sorry, what have I written? W2 by M2. Here, W1 by M1. And here, the solvent is water. So taking that, and 1000 gram, weight is 1000 gram, because molarity is 1 molal, means 1 mole of the solute is mentioned there. So 1 mole of the solute is already mentioned there. So N2 is equal to 1 mole, and here N1, it's 1000 gram of the solvent, and you know how to find out a number of moles. This one, 1000 gram of the solvent by 80, and try to remember this value is always 55.55, and number of moles of solute is given in the question already. So here we have, so number of moles, can you hear me? Sometimes. Okay. So here NB is given. I follow the NCERT pattern. So it's N2. 2 is for solute and 1 is for solvent. So this information we are getting from 1 molal is mentioned. So 1 mole of the solute. And this information we know that 1 mole means 1000 gram of the solvent. So weight of the solvent is 1080, So NB we get. Okay. And this part, it's told to us 70% dissociate. So accordingly, initial is 1. There we know this part 0, 0. So 70% means 0.7, as I have written it here. 70% means 0.7 parts is decomposing. So 1 minus, so accordingly 0.7, and here 2Cl minus means 1.4. So, and here we are using this particular formula, alpha equal to I minus 1 by N minus 1. So from this we find out the value of I. Okay. Using this you find out the value of I, and you get the value to be 2.4, because MgCl2, as we have seen here, 2 ion and 1 ion. So naturally N equal to 3 without doubt. So, and 0.7 is the alpha value. So accordingly, using that we get I value 2.4. And now when you know is I value 2.4, you know that we, for this kind, if it's electrolyte, we use the I factor here, as well as we have the I factor here. Colligative properties dependent on that. So based on that, we have it, this one. So we get it here, 1 by 55.5 here, 56 here. We can see, let me tell you, here both answers are accepted by the boards. Let me tell you, you can either use this, or you can, actually I tell students to use this only, NB by NA. Both are considered, because in colligative property we are told it's a very dilute solution, where the number of moles of the solvent is much more than number of moles of the solute. So number of denominator, the solute number of moles we can neglect. So it becomes NB by NA. So if you even keep here 1 by 55.5, that is will also be accepted. Okay, you both, even this they have shown this format and given the answer. Even if you do the answer like this, that delta P is equal to I into X2. X2 means I into NB by NA. That is I means 2.4 into 1 by, if I even write here 2.4 into 55.5, that is also accepted. Okay, wait, I'm doing it clearly. Wait a minute. Here I'm writing. NB is 1 and here it is 55.5. This into 2.4. So both are accepted. Answer variation becomes very less, but both are accepted. So this lessons are calculation part, nothing more than that. Here you have to add and then again you have to divide. So this lessons are here the calculation is simple one. They have given 1 mole, so it's simple. But sometimes the calculation becomes much more tricky when you have NB by Na plus NB. So this is very simple numerical. Only we have to remember that I factor is important here. That whatever we do, like if we do delta TB, we do Kb into M. But for electrolytes or for molecules with associate, for that we use a I factor. Similarly, delta P by P0 we write as mole fraction of the solute. But if it's an I factor here, we multiply with the I factor. Like that, we have to use this concept. Okay. So with this, can I move to the next question? Now, this type of question, usually they don't give 3 times. You have in a sample paper, but Nernst equation only same questions twice, usually they don't give. The reason being is if by chance a student doesn't know Nernst equation, he will just miss out all 3. Usually they don't give, but yes, here it's given, so we'll do it. Now we know Nernst equation, general thing we know very well, E equal to E0 minus 0.059 by N. N is the number of electrons exchange. We can see here nickel to Ni2 plus 2 electrons, Cu2 plus 2 Cu is also 2 electrons. So here the thing is very simple one. So we write here 2 log of, log means right by left. So Ni2 plus is obviously right. So, and stoichiometric coefficient is perfect here because for both the electron exchange is 2. So, it's simple, Ni2 plus molar concentration, by left side we have Cu2 plus, so Cu2 plus concentration. So, simple as that, this is the first one. Coming to the second one. Now, aluminium to aluminum sulfate means 3 electrons are getting exchanged, right? But Fe2 plus to Fe, 1 electron is getting exchanged. So here we have to multiply, like you can see here, or if you balance also you can do it because they have given already this one. So anyway, aluminium to aluminum sulfate means 3 electrons means, and this is 2 electrons means you multiply aluminium with 2 here. That means number of electrons is equal to 6 now, isn't it? Are you understanding what I'm telling? Look here. Aluminium to aluminum 3 plus. Here minus 3 electrons. And Fe2 plus 2 Fe. Here it is 2 electrons. Right? So we need to balance the number of electrons. So you multiply this with 2. So here it is 2, here it is 2. So here it becomes 6. 6 electrons in total. So you multiply this with 3. So this becomes again 6 to make it that 6 electron. Right? So I'm changing here itself because we have the answer in the next page. You can have a look. So in this case, the number of electron becomes 6. I'm making this 2. 6. And what we can see? Aluminium 3 plus stoichiometric coefficient 2 and Fe2 plus stoichiometric coefficient 3. So we have to incorporate that. So I'm changing this part. Log. On the right we have aluminium. So aluminium we write here 3 plus. Stoichiometric coefficient is 2. So that raised to the power of that. Don't go wrong with this. The common errors that we find while checking is this. Fe2 plus. Stoichiometric coefficient is 3. So we write here 3. That's the second Nernst equation. Okay. The third one, they have given a cell reaction. They have not given a cell reaction. They have given the representation of a cell. Okay. Now, here right side means this part is the cathode and left is the anode. So we know that cathode means reduction is taking place. So here Ag plus electron gives Ag and Mg minus 2 electron gives Mg2 plus. Okay, they have given 3 Nernst equation but 3 different concepts. So yes, the question can come. So Again the same thing, number of electron needs to be balanced, so I multiply this with 2. So this becomes 2, this becomes 2, this becomes 2. Right? So on to the right we have Mg2 plus, I am changing it here only. So 2 electrons here, so I write it 2. And this part I am rubbing, this is 3. So on to the right we have Mg2 plus with stoichiometric coefficient 1 only. And on to the left we have Ag plus with stoichiometric coefficient here 2. So that raised to the power of 2. So we get the answers in accordance to that. We can check the answers here. Since I have rubbed and shown you, you can have a look here. Yes, have a look. See if any error is there. Sometimes there are typing errors also here. I am also checking. Toluene on treatment with chlorine in sunlight gives benzyl chloride, where when treated with chlorine in dark gives orthochloro and parachlorobenzene. You have to explain. Now here you are mainly going to write toluene on reaction with chlorine in sunlight is a substitution reaction, where the benzyl radical, you can mention the benzyl radical, the intermediate benzyl radical ultimately forms the product as benzyl chloride. It's a homolytic cleavage reaction. In case of benzene reacting with chlorine in the dark, it's electrophilic aromatic substitution. In this case, it is electrophilic, where the electrophile Cl plus, let me look at the question where is chlorine, toluene, no? Okay, where the electrophile is Cl plus and the methyl of toluene is an orthopara orienting group. So I repeat the points mainly. The first one you are mentioning that it's a substitution reaction, it's a homolytic cleavage where the benzyl radical, because it's a benzyl radical only formed, so the intermediate benzyl radical forms benzyl chloride. But when toluene will reacts with this condition, whatever is meant, here it's a electrophilic aromatic substitution and methyl of toluene is a orthopara orienting group which forms a mixture of ortho and para chlorobenzene. The Cl plus is the electrophile in this case. So that is your answer. These points if you write, you get the complete marks. Now, Phil-Kinston reaction is used to carry out in the presence of dry acetone. Now, if you remember Phil-Kinston reaction, you take any Rx, X here can be either Br or Cl plus NaI. You get here alkyl iodide plus you get here NaX, which is NaCl or NaBr. Now, here we are using dry acetone because NaBr, NaCl is insoluble in acetone. It's dry means no water present. So, since it's insoluble means it's forming as a precipitate, isn't it? And as a result, forming as a precipitate means no longer part of the reaction mixture. As a result, as per the Leschner principle, the equilibrium shifts to the right. Because if you remove one of the reactant, equilibrium shifts to the left. Here you are not removing, it's getting removed by itself. Because the product formed, since it's forming a precipitate means no longer part of the reaction mixture. Okay. So you have to write that the product formed NaCl or you are writing to write the reaction like this I have written NaCl or NaBr that is insoluble in acetone. As a result, as per Leschner principle, the equilibrium shifts to the right and the product yield increases. That's the second part. Now, neopentyl chloride has lower boiling point than isopentyl chloride. So here you are mentioning neopentyl. We know that as the branching increases for the same molecular mass compounds, as the branching increases, what happens? The van der Waals interaction decreases and as a result, the boiling point decreases. So as the branching increases, the surface area decreases, van der Waals interaction decreases, so the boiling point decreases. That's the answer to this question. Okay, something is being told here. Let me have a look, Aishwarya. So you can check the answers always to the point, but yes, here the decrease in van der Waals interaction should be mentioned. Okay, these are the key points. Surface area decreases with increasing branching, van der Waals interaction decreases. It's actually 1 mark question. Surface area decreases half mark with increase in branching, and van der Waals interaction other one half mark. Like this usually they give marks. The relation to a principle right, and this also I have told you everything. They have written their answers in their own way, but the vital points, the difference you have to mention the type of reaction in both the cases, which is the intermediate one in the first case, the second case Y orthopara, so you have to mention there the methyl of the toluene is the orthopara orienting group and the Cl plus is the electrophile. That's all. Okay. Now here is a question taken from this is taken from D block elements. See, which of the following elements will exhibit similar magnetic behavior and why? Now here by similar magnetic behavior, if you look at the question very well, you will understand that they are meaning not paramagnetic or diamagnetic. You have to find out even if it's paramagnetic, that means it is having unpaired electrons. But if a particular ion is having suppose 2 unpaired, another one is having 5 unpaired, so will the paramagnetism be same? Of course not. The magnetic moments will be different. So that is also being indicated here. So here you have to point out the ones which are having same number of unpaired electrons. So that will have similar magnetic behavior. That's the first part of the question. Here that's a result. Here atomic numbers are given. So it will become easier for you to find out. And for the next part, form white salts and why. Here, if you remember, salts are white only when there is no DD transition. That's the vital answer for why. And when there is no DD transition, when either D electrons are 0, that is D0 configuration, or fulfilled D electrons, that means D10. So for only D0 and D10, no DD transition will take place. So that again you have to find out from here. Okay. Now here the main thing is, see, salts means ions. So you don't look at zinc. You have to think for zinc, which is the only oxidation state possible for zinc. We know that it is Zn2 plus, which is D10 configuration, 3D10. Similarly here, scandium. Here the element is given, but here they are asking you many concepts together. They are asking you which is the common oxygen state for that particular element, whether you know or not or that. If you don't know that, you will not be able to answer this question. Again, also the concept of DD transition with D0 and D10 configuration, they will only form white salts. So again, for scandium, you have to understand and remember that scandium only 3 plus state is possible. So this is only 3 plus it is possible. 21. 21 means argon is 18, 19, 20, 21. So that means D has no electrons. So here 3D0 is the configuration, isn't it? Because 18 is argon, then 19, 20, 21 means all 3 electrons are lost because scandium, I told you 3 plus. So here we are getting the D10, so these two will form white salts. If you look at nickel, nickel is 28, it is D8 configuration because nickel common oxygen state is Ni2 plus. So D8 will, so only for D0, D10, there will be no DD transition, so the salts will be white. So this will be colored. Vanadium again 23. Vanadium also 2 plus is possible, 3 plus is also possible, but 2 plus is also possible. So 18, 2 plus is possible, 18, so D1 configuration is there. So taking this account, this is the answer. And so you are answering as well as giving the reason. So reason will be for this two you are mentioning 3D10 and 3D0 configuration. So no DD transition is possible. That must be mentioned in your answer. Without that, you will not get any marks for justification. And this I already told you, this I am not finding out with configuration. We look at the answer directly. But I told you, you have to find out the same number of unpaired electrons. Not only if they are unpaired, it will not do. Same magnetic behavior means here the unpaired number of electrons should be same. That also you have to check. So chromium, you can see here. 3D5 S1 means 5 plus 1 6, 5 plus 1 6. Okay. Same number of unpaired electrons. For the rest, if you check the same number of unpaired electrons, you will not be getting. So here you can see D5 means 5 unpaired and S1 means 1, 5 plus 1 6, same for molybdenum, 5 plus 1 6. So same number of unpaired electrons means that they will have same magnetic behavior. So that was this question. I'm moving to the next one. Okay. This is a very good question. Read the question first. Okay, all of you. So oxidation of ethanol presence of acidified dichromate. Now we know that ethanol will give us ethanoic acid. So we write here CH3. I'm not writing the reaction now. We'll see in the answer. Ethanol gives us ethanoic acid. Reaction of propanoic acid and bromine in presence of phosphorus. We know that alpha hydrogen is getting brominated. So propanoic acid means 1, 2, 3 and here it is COH. Alpha carbon is this. This is getting brominated. HBZ reaction, if you remember. CH3, CH, this one. We get reaction of isopropyl magnesium bromide with carbon dioxide followed by hydrolysis. Isopropyl means CH3, CH3, hydrogen, isopropyl is done. Magnesium bromide plus carbon dioxide will give us corresponding carboxylic acid. So we get here COH group. Okay, isopropyl magnesium bromide. So this is for C. I'm not writing the reaction. I'm just writing straight away. Reaction of propanoic acid with chlorine in presence of red phosphorus. Similar reaction. Only difference is we are getting a Cl there. So CH3, propanoic only they said, no? Yes, CH, Cl, COOH. We get here. Now, pKa told to us, so we know more is the strength of the acid, lesser is the pKa value. That means stronger the acid, lesser the pKa value and vice versa. The strongest acid of the lot, we can know that if an electron withdrawing group is there, the acidic property increases. So electron withdrawing group is present for Br and is present for Cl. But we know Br is more electronegative than Cl. So for obvious reasons, B will be most acidic. So pKa value will be minimum. And they have told you to order increasing order. So small to big. So smallest will be B. So I write here B. After that will be chloro is present where D. So after that it will be D. After that, as minus I groups or electron withdrawing group increases acidic property, electron donating group will decrease the acidic property. So it's electron donating group and here it's nothing. So after that will be A. So it will be A and minimum acid strength or maximum pKa value will be for C. So for writing this order, so the order you can write with respect to BDAC. That is perfect. You will get 1 mark. But yes, you have to show how you are getting A, B, C, D. For that, your marks are allotted. So just have a look at the reactions. Order is given. And okay. Here the complete answer probably is not shown. But if you check the answer properly in your textual part, you will see that that A, B, C, D, they are shown. Now, since I have already mentioned that A, B, C, D, what they are, so you have to show the reaction or you have to identify, as I told you, because it's 3 marks question. Just for writing the order, you will not get 3 marks. For if you identify first, you get half into that and then you write the order. That's the concept of the question. Okay. Anything you want clear till here? Let me know. Here again, any 3. Like I told you, there's a question where you get, there are 4 questions you have to attempt any 3. We'll do all of them. But as I told you, you will be first writing the reactants and products. So butane 2-on, 1, 2, 3, 4. 2-on, this one, 2, 3-methyl pentane 3-ol. So pentane we'll write 1, 2, 3, 5. 3-methyl means 1, 2, 3. 3-methyl pentane 3-ol. Okay. Yes. Now, have a look at this. How will you think? We know that from this OH group, you are getting the, the keto group, you are getting the OH group. Now, to this carbon, there is a ethyl group. So I can consider this is the ethyl group. Already there. To this carbon, there is a methyl group. So of the 2, I can see the methyl group is here. So what we got extra from here? Extra we got the ethyl group. Extra we got the ethyl group. So from where did we get the ethyl group? By Grignard reaction only we can do ethyl magnesium bromide. We know that from ketone we get a tertiary alcohol, isn't it? So what will be the Grignard reagent? The extra one which we get here, ethyl. So here I write, you can for conversions I am writing ethyl magnesium bromide, and step number 2, it is H3O plus, we have to hydrolyze. If we do that, we are going to get CH3, CH2, COH. This methyl was there. From ethyl magnesium bromide, I got CH2, CH3. Okay, so this is the answer. First part done. Next is anisole to 4-methoxytoluene. So I am writing anisole is this. Anisole is this. 4-methoxytoluene. Okay, if I write like this, it will be a problem. This only they gave, no? So it's very simple. You can simply do Fiddlecraft reaction with methyl chloride. So I'm writing the reagent here because you are only keeping methoxy group and methyl here. So I can write, you have to, don't forget CH3Cl in presence of anhydrous. Don't forget to use this anhydrous AlCl3. This will give you this from this. You get both para and ortho, but para is obviously a major product because of steric reason. Ortho is the minor product. So done with the second part. Next. Okay, phenol to benzene is one-step reaction. We have only one reaction where the phenolic OH bond is cleaved, zinc and heat. So I'm not writing the reaction like that. I'm simply writing in short PHOH, phenol with zinc, and you heat, you get PHH. One-step reaction. It's not a conversion rather. Then chloroethane to ethoxyethane is again a very easy thing they have given us. Chloroethane to ethoxyethane. So chloroethane is this. To ethoxyethane is this. This they have given very easy. I don't know for the boards whether they'll give us so easy or not. It's simple. We know that chloroethane we are getting here. Ethoxyethane means we are using this. Sodium ethoxide. Wilkinson's reaction. This you get and you get the product. So the reagent is sodium ethoxide will give us this product. Nothing more than that. It's a one-step reaction. So here you can have a look. The things I have told you. Ortho and para, they have highlighted both, but they have mentioned here 4-methoxy is a major product. If you want, you can only write para-methoxy because for conversion they have not asked for ortho. You just write para-methoxy methyl group, that toluene you write the structure. Below that you write major, that will do. Even if you don't mention ortho one, it will not harm you. Okay. So yes. Now we come to again a D block question. Are the enthalpy of atomization of zinc and copper matched correctly? Now for this, let me give the introduction and you have to justify. So we know that enthalpy atomization depends upon the number of unpaired electrons. And the thing is, more the unpaired number of unpaired d electrons, more the number of unpaired d electrons, more is the intermetallic bond, and so greater is the enthalpy of atomization. So for zinc we know it's D10. So no unpaired electron present. So we know also that enthalpy of atomization is minimum for zinc. But here it's reversed. So the answer is obviously no. Because zinc will have minimum value of enthalpy of atomization as it has 0 unpaired d electrons. And for copper at least 1 unpaired electron is present. Isn't it? Copper is D10S1. So unpaired electron is present. So copper will, this is the reverse. So zinc should be this, copper should be this. These things we'll check in the answer because I'm not writing the answers here anymore because these are not conceptual questions. These are directro questions. So those which are conceptual like the MCQs I told you, I'll highlight more on that. But which are directro, we can simply see the answers from here because this nitrate make a reaction. See these reactions is very difficult to remember. We think that we will not study that, but if you don't study that, you will miss 2 or 3 marks. It comes each year. So try to memorize those, write and practice. Okay, this is one of them. And yes, the previous question I missed out, sorry. Out of sulfuric acid, hydrochloric acid, which acid will you prefer for permanganate nitration? Of course, sulfuric acid will prefer, because hydrochloric acid is first of all a volatile acid. Moreover, from hydrochloric acid we get chlorine. If you remember, using an oxidizing agent, it gets HCl gets oxidized to chlorine gas, so the reaction will be different. So we use sulfuric acid. Okay, so that's it. We have done this part, and next question I move to. Okay, as I told you, here you mainly for this questions you have the answers in the paragraph. Okay, for this year they have given that. So they have given here a lot of information. So first part of the answers you'll get in the paragraph itself. You have to read the paragraph. So not always you will read the paragraph. I would suggest you look at the questions first. If you think that yes, the questions that are given to you are not in the textual part, it's not in your, because nothing will come outside NCERT. Anything which is not mentioned in NCERT, you will not get a question. You'll get conceptual questions a lot, but the concepts are there in the NCERT. But information not provided in the NCERT and you're given the question, you don't get such questions. So if you read the question, like here, I'll see the question, I'll show you the questions, and you see, will find that no, the answers are not there in NCERT, then you have to read the paragraph. So that way you can try, because reading the whole paragraph, because 70 marks paper, 3 hours, it takes time to write for class 12. Okay, so I'll go to the questions first. Look here. Is it possible to identify whether given solution is 1 molar NaOH using a conductivity meter? Justify your answer. Then what is the possible pH value of solution glow green in LED and all this? See, these are there in the textual part. Here everything LED and all. So you have to find the answers from here. Here I've seen this question before, so I know that all the answers are mentioned in the like substances that do not conduct electric current are called non-electrolytes, that we know. Non-electrolytes do not ionize, that also we know. Now they do not contain movable ions, same thing we know. LEDs of a conductivity meter will not light because there are no ions, that's also we know. But then this table is given us that for scale, see, scale is given to you. So conductivity is low, more or high. What is the color? Red LED, all you get. So even for high, for green LED, you get dim. For red LED, you get bright. So are we informed of this? We know. Physicists are very much aware of this. But for us in chemistry, electrochemistry, we don't these things. But these informations are provided to us in this paragraph. So we have to answer from the paragraph itself. Okay. So we'll see this informations we get from the paragraph. See, refer to the table given below and draw the molar conductivity. Okay, so here. So we saw there that for non-electrolytes, LEDs do not glow. I've shown you one part. No ions are present. So that's the reason why no, both are strong electrolytes. So both the LEDs will glow. And red will be bright. C for strong electrolyte. Green will be medium in both the cases. Because there the scale was given. So from there you get the answers, and this part of the question is from the textual part, because here the question was asking, we know that A is a strong electrolyte, B is a weak electrolyte. We know the information from the textual part, and we know now, and from the NCERT part we know that for strong electrolytes the graph is a straight line which do not touch the x-axis. So limiting molar conductivity we can find out by extrapolation. But for weak electrolytes, the graph is like this. So by extrapolation, we can't find the limiting molar conductivity. We have to use the Cole-Roche's law to find out that. So this diagram, again, we know that molar conductivity versus root over of concentration. This graph we have to draw, which is the concept. It's from the NCERT text. Okay, but the rest part, whatever here, is the concept taken from the information should be gathered from the paragraph itself. Okay. Now, this again, it's also similar thing, a lot of being told about hemoglobin. Okay, iron, hemoglobin contains iron. So if you are less in hemoglobin, you are given iron tablets, but iron tablets also cause constipation. So you have to have a balance of the both. So you can also, not only tablets, you can also eat food supplements which have rich iron content. So this is the concept given here. It's a question taken from coordination compound concept, because they are talking of, if you read the whole thing, I'm not reading the whole paragraph, it will take a lot of time, but here if you read it, you will find it's a coordinations complex. You can see from here, these are different ligands which is coordinated to the central metal atom Fe. Okay, this part is ethylene diamine, this part is oxalate with NH2 group, so this is a whole complex. Now, this part of the question is not taken from the paragraph. We have to use our own concept. How? See, why is Fe3 EDTA complex stable as compared to ferrous sulfate? Now, here the concept we know that a chelating complex is a more stable complex than a non-chelating one. So that will be our answer. Chelating complex means cyclic thing. So chelating complex, so EDTA is a polydentate ligand and it forms a chelating complex with, so you can write like this. EDTA is a polydentate ligand, in fact it is hexadentate ligand, and so Fe3 EDTA complex is a chelating complex and so is more stable than ferrous sulfate. So this is the answer to this question. Next. What happens when hard water is treated against Na2-EDTA? So that you have in your part. You are doctor working somewhere, you will recommend iron fortified food to your patients. Density of a ligand, we know polynate it's 6. Density is equal to 6. Name the atoms to which it can bind through sentimental atom. EDTA structure you need to know. Ethylene diamine tetraacetate, isn't it? So ethylene diamine tetraacetate is the structure. I'll show you here. CO2 minus and NH are the, wait a minute, here, this one. Ethylene diamine means, why ethylene diamine? Ethylene diamine is this, CH2, CH2, NH2, NH2. This is ethylene diamine, and tetraacetate means to this NH2, tetraacetate means 2 here, 2 here. So this acetate group is bonded, CH2CO minus is bonded. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's 6 hexadentate ligand. Denticity is equal to 6. And the question asks you which are the donor atoms. So we can see here both nitrogen and oxygen are the donor atoms. Okay. Okay, that's all for this part. But the other questions are taken from the paragraph itself. Now we come to question number 31. Question number 31 is a 5 marks question we are having now. Write the structure of expected product of Cannizzaro reaction of 2-chlorobenzaldehyde. Now Cannizzaro reaction, if you remember, the aldehydes reaction take place only for aldehydes. That's point number 1. Point number 2, which aldehydes? Aldehydes which do not have alpha halogen atom. That's point number 2. And it's a disproportionation reaction. That means one aldehyde is getting oxidized to the corresponding carboxylic acid. In fact, sodium salt of carboxylic acid. Why sodium salt of carboxylic acid? Because the medium is basic in nature. So it doesn't remain at carboxylic acid, it remains as sodium salt. And the other aldehyde gets reduced to the corresponding alcohol. Okay, so based on these points, first we write 2-chlorobenzaldehyde is this. 2-chlorobenzaldehyde is this. So they told us to write the structure of the expected product. We don't have to write the reaction. So we'll write the structure of the expected product. So answer will be, as I told you, one of the CHO will be reduced to CH2OH and the chlorine remains, and the other product will form the sodium salt of carboxylic acid because the medium is basic. So I write this. So first part of the answer done. Achha, how will the effect of the SO3H group affect the basic strength of the acid? Here SO3H group is a electron withdrawing group. This is the first thing you have to write. It's an electron withdrawing group, and so the basic strength of aniline will decrease because we know that electron withdrawing group decreases the basic strength of amines and vice versa. Done. Convert acetic acid to ethanamine. So we'll do that and write with a different color. Acetic acid is this and ethanamine is, I'm writing it here, this, and this. So we can see again here one carbon has increased. You can increase the carbon atom. How? So I do it here. I convert to CH3, C. No, one carbon atom increase in carbon number is same, but carboxyl group to CH2 NH2 group conversion. So if here you have to remember the preparation of amines. In the preparation of amines, one of the preparation is you can convert amide to an amine by lithium aluminum hydride reduction. And we know that we can convert acid to the corresponding amide, CONH2. What is the condition? It is ammonia, and not to forget heat. Heat you have to mention. And this, when you treat with either lithium aluminum hydride or you treat with hydrogen palladium, you get the CO group gets reduced to CH2 group. So that's the preparation here. Then write the steps to prepare benzoic acid from benzoyl chloride. So here I'm writing this here, number 4. Benzoic acid prepare benzoic acid from benzoyl chloride. So here PHCOCl, we get PHCHO. From there we can prepare PHCOOH. And how you do this? It's Rosenbaum reduction. Hydrogen palladium. Oh my God, what have I done? I have to call somebody. Wait, something I have touched. Wait, undo I do? Yes. Okay. This is Rosenbaum reduction. Here you use hydrogen, palladium in presence of barium sulfate. You get this, and this any strong oxidizing agent like acidified sodium dichromate CNA2Cr2O7. Only thing is acidified you have to write. You get this. Okay. Give a chemical test to distinguish between propanal and propanone. That means here you have to distinguish between aldehyde and ketone. You have 2 tests, tolerance test and Felling's test. You write the name of the test. I would prefer you write tolerance test because benzaldehyde will not respond to Felling test. It's an exception because benzaldehyde pH group makes the aldehyde group very less acidic to respond to Felling test. So you write tolerance test. So you mention the name of the test. By tolerance test we are able to distinguish, and you write the observation. Where you are going to write propanal will give a silver mirror, whereas propanone will not give a silver mirror. That's it. So with this we finish this part of the question. You can have a look at the answers. Since I have drawn, as I told you, this is the electron withdrawing group is the main part. Electron withdrawing group. Here they have done it like this, but I have shown it in a much lesser steps. See, they have gone a long way round. You don't have to. Direct, this is my better conversion is this, which I have shown. Direct from the acid, ammonia, heat, you get the amide, and this amide when you reduce, you get ethanamine. You don't have to do so many steps. This is a better conversion than the sample paper has given to you. So I would like you to follow this, because there the steps are more. Both are correct. It's not incorrect. But more lesser steps means it's a better conversion always. So this is the one. So next let me check. Benzoic acid to benzyl chloride. Okay, Rosenbaum, and then acidified KMNO4, acidified sodium dichromate. Whatever you write, both are correct. Okay, after this, chemical test. Okay, tolerance. I told you for writing the name of the test you get half mark. And for writing the observation for both you get another one half mark. So you don't have to write how you are doing it. That's enough for writing. Okay. With this I move to the next question. The or question of this part. Just read the question. Coming to Wolff-Kishner. Do you remember what is Wolff-Kishner reduction? It is C double bond O getting converted to CH2 group. That's Wolff-Kishner. So we'll write the structure. 2-methyl-butanal. 2-methyl-butanal means butanal is 4 carbon atoms. Last one is CHO group. And 2-methyl is here CH. And so from here CH to CH3, I mean CH double bond to CH2, you get an alkane. Straight away I'm writing the name of the product here. It has to be CH3. It has to be CH3. So first one done, only the structure they had asked you. So you can simply write this. Next is how would the presence of SO3H group affect the acidic strength of benzoic acid? Here it will be reverse. Same answer you're going to write. It's an electron withdrawing group. and electron withdrawing group increases the acid strength, increases the acidic strength, because it stabilizes the conjugate base more with respect to that of the acid. So same thing, because we know that electron withdrawing group will decrease the acid strength and electron withdrawing group will increase the acid strength. Isn't it? The same thing we had seen for the question. We had to arrange an increasing order of pK value, bromo, propanoic acid, alpha bromo, alpha chloro, all that same concept. Okay. Prepare acetic acid from ethanamine. Now they have given us ethanamine, they have given, and from this you have to prepare acetic acid. Okay. If you think at it, it's a primary aliphatic amine. This with nitrous acid, it gives us an alcohol. This diazonium salt is quite unstable, isn't it? And that gives an alcohol. So this alcohol, similarly, when you oxidize in presence of acidic KMnO4 or potassium dichromate acidified, you get the corresponding acid. So you get this on oxidation with a strong oxidizing agent. You get this. So done. Now aniline to benzoic acid. Okay, before that, propanal ethanol. I'll do this. Okay, aniline to benzoic acid, let me do that first. Aniline to benzoic acid. This is aniline. This is again not difficult. Aniline to benzoic acid. This we do by Sandmeyer, diazotization concept only. This one, sodium, you have to write the right condition. Sodium nitrite, HCl, 0 to 5 degrees centigrade. Don't forget to write this temperature. Okay, it's very vital. You get here N2 plus, then CuCN, you get here cyano, and then you do acidic hydrolysis, you get benzoic acid. So aniline to benzoic acid done. Okay, and the previous question, chemical test between propanal and ethanal. Yes, ethanal will give iodoform test, propanal will not. So it's an alcohol which gives iodoform test. So you can write iodoform test, and iodoform test is the name of the test, and you can also write that ethanal will give a yellow precipitate with iodoform test, whereas propanal will not. Propan-2-ol will, but propanal will not. Propan-2-ol gives propan-2, but propanal will not give that. So that's all with this part. We'll check the answers. Have a look. Wolff-Kishner, I told you it's an alkane. Then let me see the conversion, what they have done. Yes, they have done the same thing. You can use any common oxidizing agent. And this one, electron withdrawing group given. This also is the same thing. Yes, here iodoform test, yellow precipitate with iodoform test, this doesn't give. That's all with the question number 31. Then this is 32. Acha. Identify biomolecule question. Identify and give any one point of difference between protein present in hair and protein present in egg albumin. Yes? Fibrous protein and globular protein, isn't it? Hair. We know they are insoluble in water, soluble in water. You can also simply write that. There are many points, but you can write that because hair protein. So you have to mention it's a fibrous protein present in hair, and albumin, it's a globular protein. And then you mention the difference. Any point of difference you can write, but I choose the easiest of the lot. It's an insoluble in water, that's soluble in water. Acha. Both glucose and sucrose have aldehydic group. Then why does only glucose reduce Felling's reagent and not sucrose? So here the key answer, you can write a lot of things, but the key answer you're going to write that in glucose, the free CHO group is the glycosidic, the free CHO group is available. So it reduces this, whereas in the sucrose, due to the formation of the such glycosidic bond, the free CHO group is not available. The free CHO group present or is absent, that's the vital part of the answer. That is what they mainly ask you. Okay. Now, why do amino acid behave as salts? So here you can write the structure of a general amino acid. It's alpha amino acid, so COH group and NH3 group. It's hydrogen. It can be anything. So, NH2 group. So you're mentioning here that both acidic carboxyl group and amino group is present. So it can exist as a veteran and thus can form sols. That's the answer. Because main thing is both the acidic carboxylic group and amino group is present. So they can form sols. Okay. What chemical change take place during curdling of milk? Now here the answer which they have mentioned, it's not a part of the biomolecule chapter. They have mentioned the conversion of the lactic acid formation. But I would suggest you also mention in curdling of milk, denaturation of protein take place. That also you can mention. And so we'll see the answer. Next question, you see, doctor advised a 50-year-old woman enough exposure to sunlight and addition of fish and egg. Exposure to sunlight, why? Because vitamins, we all are vitamin D deficient. We live in ACs, less of sunlight. So vitamin D deficiency, obviously. Addition of fish and egg yolk to her diet. What the possible disease diagnosed by the doctor? Okay, so we'll look at the answers here. See, as I told you, fibrous protein. Here there are many things they have mentioned, but they have asked you only one point of difference. So you will have to specify the protein that are present in the hair and the albumin, and then you write any one point of difference. Okay. This was, I was telling you, free aldehyde group. This is the main part of the answer. Free CHO group present or free CHO group absent. Okay. And here, see, chemical change takes place in the curdling of milk caused due to the formation of this. They have mentioned this. Lactic acid from lactose sugar by bacteria present in milk. And here, denaturation of protein is actually taking place. The primary structure is lost, but they are asking of the chemical change. So they have highlighted this part of the answer. And yes, vitamin D rich diet, vitamin D deficiency is taking place. Vitamin D deficiency means osteoporosis, the biggest 50-year mentioned. Now see, we intake calcium to strengthen our bones, but if the vitamin D is deficient, then calcium absorption by the bones will not take place. In fact, they may lead to stone formation, calcium stone formation. So vitamin D deficiency is very bad for our system. First of all, we have to either take vitamin D course, medicine course once in a year, as well as be in the sunlight and eat a lot of protein that is enriching the vitamin D system in our system, body system. So that's the part. So it's vitamin D rich diet they have mentioned, and this is osteoporosis, a very common problem at old age. Okay. So after this, the or part of the question, identify and give any one point of difference between the carbohydrate present in cane sugar. It's a similar type of question, and carbohydrate present in milk. Okay. Glucose is an aldohexose, and second question you see glucose is an aldohexose and a monosaccharide, while oxidizing agent should be, glucose is an aldohexose and a monosaccharide. Which oxidizing agent should be used to bring about oxidation of only aldehyde group present in glucose? We have done this, it's bromine water, because if you use nitric acid, then both the aldehyde group and the primary alcohol group gets oxidized. So amino acids, which is mentioned here, predict whether the pH of this amino acid will be greater than 7, 7 or more than 7. That depends on the relative number of carboxylic acid group, NH2 group present. So here we see there is two carboxylic acid group, but there is only one NH2 group, so it's more acidic. So the answer should be less than 7. Okay, and here it is bromine water. We have the answers at the back, so we'll see there only. Name the two major molecular shapes due to folding of secondary structure of protein. We know that beta pleated sheet and alpha helix structure. And Ashish's gums bleed frequently. Doctor's prescription mentioned Ashish is suffering from scurvy. Help him to identify the food sources. Yes, again, this part, the table that you have for vitamin D, I told you, those food supplements, what leads to what, that is very important. You have a table there, you get 1 mark or 2 marks question from that part. So we'll look at the answers. because I want to finish it today so that you don't have to join some other day again, isn't it? Because for one question, just having in a class, better you study. If you have doubts, you can mail. So what was the question? Oh, this question I missed out, no? Identify and give one point of difference between the carbohydrate present in cane sugar, carbohydrate present in milk. Oh, monosaccharide and okay. So here, cane sugar, sucrose, and disaccharide composed of glucose and fructose, while carbohydrate present in milk is lactose. Disaccharide composed of glucose and galactose. Done? Bromine water is the answer. Such big answers not required in chemistry. Just the answer, bromine water in this case. That's it. A weak oxidizing agent. And this is also, here they have, they asked you to justify? Let me check. Predict whether pH of amino acid will be here. They only have asked you to predict. So if you get less time, suppose you have very less time, you want to finish, then you try to stick to the question. Just pH 7 will do. But yes, if it's better, you just mentioned here COH group 2 hyphen 2, NH2 group hyphen 1. pH is less than 7. If you have less time, at least write like that. The examiners usually understand that you know the answer. Okay, if you have less time, don't write big answers in words. I move to the back part. Okay, yes. This also, just simply alpha helix and beta pleated sheets. Only that. You don't have to write that the two major here, not required. In chemistry, not required. Just the answer you write. Okay, you don't have to write such big statements. Don't waste your time in that. And here, yes, any food supplements you are giving. So there are many: citrus, amla, green leafy vegetables. That's all. Okay. So done with this part. Yes, last question we have come to. This is based on chemical kinetics. Rate of a reaction triples when the temperature changes from, triples means 3 times. It increases. That means T1 is 298, T2 is 318 Kelvin. Calculate the energy of activation of the reaction. If you remember, in one of the PYQs, we had done this question, this type of question, because this question comes quite frequently using the formula log K2 by K1 equal to 2.303 A by R. That question comes very frequently. So we'll just go to the solution directly here. Yes. This is the formula. Always write the formula. For the formula, half marks are allotted. And since the reaction rate triples, so we know it's 3. So you like log 3, you write it there. Log 3 or some values are given. Let me check the question. What is given? R 8.314 given, log 3 value is also given. So everything is given. So you calculate, and what to tell you, not to forget the unit, because for the answer part you have 1 mark which is given half plus half. That means half mark for this answer, half mark for this unit, and the rest part marking comes here. So if it's a 3 marks question, 1 more half will come here. So 1.5, and the rest marks comes from here. Okay, so don't forget to write the unit with your answer. That is very important. And this is the formula to be used. Don't forget this formula. It is E alpha given, but it's not E alpha, it is EA. By 2.303 R, 1 by T2 minus T1 by T1 into T2. So this is done. Now, identify the order of the reaction, write the integrated, okay. Identify the order of the reaction, you can see here. And write the integrated rate equation mentioning what each term in the equation represents. So you see how to writing the answers? Yes. So simply, it is also, if you have less time, I repeat, simply the zero order reaction will do. Zero order reaction, you get marks. Okay, and then you write this integrated rate equation. Okay, R minus R0 by T, you write it. And then you are told to specify. They have mentioned here specify. Even if they don't mention the question, always specify what you are using. Okay, what you are using. Concentration of the reactants, the initial concentration of the reactants, then this is the K is the rate constant, T is the time taken, and raise this concentration of the reactants at time T. That's it. So this is vital. Even if you are not told, here I'll tell you, even if you are told to write the integrated equation, mention, like suppose you are told to write the Arrhenius equation. Mention what is A, what is EA, because you write no A into e to the power minus EA by RT. So mention what is A, Arrhenius constant, EA, energy of activation, universal gas constant, R, T is temperature in Kelvin. Always specify. That part you don't miss out. But writing long answers, I tell you, don't have to. Okay? Now, next, I'm rushing a bit. Is it okay? Are you able to understand? I need to know that. Because I want to finish it in one class so that now, because you are going to give your board practicals or maybe board practicals are running, you get more time to study. Is it okay? Okay, Chanakya. Okay. Now, consider following first order thermal decomposition at a constant volume mentioned. The total pressure of the gas is found to be 200 torr. That's PT. We did this in PYQ also. PT is given to you 200 torr after 10 seconds and 300 torr upon the completion of decomposition. That means calculate the rate constant. Here also log values are given. So initially, okay, I'll not write this too much. I'm showing it from here. Yes, that's best. T equal to 0. We know that these are not formed. Only the reactants are there, right? So initial, Pi means initial, and this, the numerical based on PTPI came last year in the board exam. This is a question which came in last year's board exam in one of the sets. Actually, in whole pan India, CBSE, it's not like ICSE board. They have only one paper across pan India, but here we don't. We have like Bhubaneswar Center, you get 3 sets in one code. For other centers, other Delhi side, you get different. So they are different. So in Kolkata, the paper that came in one of the questions had this concept. So here you write the reaction T equal to 0, Pi for the, this is 0 is for the reactants. For this is 0 and 0. Now, so at T, at PT, that is when we are considering X has reacted. So its X is the stoichiometric coefficient is 1 here. The reaction has become very simple. So if X is lost, you get X and X, right? Now, so now on completion, what is the total pressure? You are adding up everybody. This part it should be. You are adding up everybody. That is Pi minus X plus X plus X. Here, Pi minus X plus X plus X. From here, you are actually getting Pi plus X. So here I am writing here. I don't know, it's not mentioned. PT you are getting here. This X and this X cancels. So you are getting here Pi plus X you are getting. So from here, X you are finding out. X is what? PT minus Pi. So this you got. Now, PT in the question 200 was given, and in the question this 150 is also given. So X you are getting here 50 torr. Right? You are getting 50 torr. Now, it's a first order reaction. So you are putting the equation. Okay. K is 2.303 by 3 log of. Initial it was Pi. Final it is Pi minus X. So here they have placed this, the initial, as we do the first order reaction, that K is equal to 2.303 by T log of initial concentration by final concentration. Here the concentration with respect to pressure. So Pi, final Pi minus X. Now X value we already have it here, 50 torr. So, and the Pi value also we have from the question. So 150 by 150 minus 50. Okay. So ultimately calculating this, let me see what we have. Yes. We have log 3 by 2. These values were given in the question. So accordingly, we plugged in the values and we got the calculation. As I repeat, not to forget the unit. It's first order reaction, the unit is per second. So we got these answers in accordance to that. Okay. This part. And the next question we had, let me have a look. What was the question? For bimolecular elementary reaction A plus B products, giving products, write the expression of the rate of the reaction related to temperature and activation energy for the reaction. Also mention what each term represents here. So instead of giving the Arrhenius concept equation, here in the answer they have given the a better approach since A and B was mentioned. Look at the question again. Here A plus B giving product. So they have not only considered the Arrhenius constant, they have here also considered the Arrhenius equation along with the collision frequency concept, where we use the collision frequency between A and B. So the answer is this. Here, rate equal to this collision frequency, and this is coming from the Arrhenius equation. Arrhenius equation, what you have? You have A into e to the power of minus EA by RT, where A is the Arrhenius constant. But more advancement went later with collision frequency, where they are also talking about the collision between A and the collision frequency between A and B, which is giving the products, and later also of the orientation of the collision. But so accordingly here ZAB was mentioned, and ZAB is the collision frequency, EA is the energy of activation, R universal gas constant, T is the temperature. That's all. So yes, with this we are done with the sample paper class 12. So study a lot, practice question answers, write, solve, and all the best to you all. Thank you.